This meeting is being recorded.
Okay, the problem with in the last class I explained what is the linear search. Here the problem with linear search is if the input space is more number of comparisons are required. Suppose if the input space means the size, how many number of elements in the list having the thousands or lakhs of elements, then you need to search the elements, more number of comparisons are needed. That is the disadvantage. The advantage of linear search is suppose the first element or last element is a searching element, you need only single comparison. Suppose here I have 60, 70, how many number of, suppose for 60, how many number of comparisons are required here linear search? Actually, 6 comparisons are required because of the first element has compared with 10, the 60 is compared with 20, 30, 40, 50 and 60. Total 6 number of comparisons are required. Suppose if the elements are more than, suppose 1 lakh elements, the last element is a searching element. Suppose if you can start from begin, then more number of comparisons are required. That's the problem with linear search. When it is best means, okay, suppose you can start the searching element is the first starting element or ending element or nearer to first element, starting element or nearer to last element. Okay, it is good. Suppose if the element is not in the not at starting or not at ending in the middle, okay, then okay, the binary search will takes the more number of comparisons to finish the search the element. Whether it is the element is found or not, that is secondary. Okay, that is a disadvantage of linear search. Now, by using binary search algorithms, how can you increase the time complexity? Time complexity means the algorithm will execute in efficient manner than linear search. That means here the how can you say the algorithm is efficient here means suppose number of comparisons are required for to such an element. Number of comparisons if you can reduce, then okay, it's the best algorithm. Okay, wherever when you can say best means okay, just you have to reduce the time complexity means you have to reduce the number of comparisons. It is a searching technique. In the searching techniques, you can reduce the number of comparisons, which is the best algorithm. Okay, then you will go to the binary search algorithm. Okay, how can you solve the binary search? Some cases. Okay, I'll, let me explain. Okay, what is the principle of the binary search here? The principle of the binary search is the first one. Principle of the binary search is this is the divide and conquer principle. Divide and conquer. Actually, this is the one of the algorithm strategy. Okay, divide and conquer technique. Divide and conquer means the problem has divided into number of subproblems. From each and every subproblem, we can find out the what is the solution. You have to search for solution. Okay, you have to search for solution. The entire problem has to be divided into number of subproblems. Okay, that is the concept of the okay, that is the concept of the divide and conquer strategy, algorithmic strategy, algorithm strategy. Next, coming to algorithm. Okay, here algorithm in the binary search. Okay, suppose the list size is 100 elements. Suppose the list size having the 100 elements. Okay, here list size is that means the array size is 100 elements or 1000 elements. 1000 elements. Okay, then you have to start the search. Okay, first of all you have to find out which is the middle. Okay, suppose before going to why do you select the middleman? When we have to select the middleman, then it is advantageous. Okay, when you have to find out the middleman, it is not sometimes it is not advantageous, disadvantageous. Because why the reason? Okay, the middleman you have to find out in the binary search means first of all the element should be in the ordered, either ordered list. Ordered list means either the list is in ascending order or descending order. Suppose ascending order, why do you take the list as ordered list means suppose okay I have the list elements having the 10 elements 10. Suppose order list 10, 20, 30, 40, 50, 60, 70, 80 and 90 and 100. Okay, here total 10 number of elements. The elements are in ascending order. Okay, suppose if you have to find out the mid element 50, once you will get the mid element. Okay, the mid element is divide the list into two sublists with uh, some kind of the what is the problem, what is the advantage here if the list is in order list, Once you can find out the middleman, okay, the list has divided into two lists, then you will get the conclusions. Here we will get the conclusion, the left list. Okay, this is called as 10 to 40 is the left list and 60 to 100 is the right list. Okay, this is the left list, this is the right list. The middle one is the middleman is the 50. Okay, what are the conclusions here? The left list elements of the middle, all the elements are less than the middleman. Okay, the right list elements are greater than the middleman. Okay, these are the conclusion. When do you get the conclusions here? These kind of conclusions, if the list is in order list. If list is not in order list, okay, then you can find out the middleman. Then we should not get the conclusion. Suppose, okay, suppose here this is the 50. Next, this one is suppose 40. Okay, suppose here the middleman is 40. Okay, now what is the conclusion here? If the elements are in sorted order, okay, the left list having all the elements in the left list are less than the middleman. Right list elements are greater than the greater than the middleman. Okay, from this example, the left list elements are 10, 20, 30, 40, 30, 50 are not one of the element is in 10, 20, 30, 50, one of the element is greater than 40. Here 40 is 50 is greater than 40. That means the condition is violated. Here the condition is violated because of one of the element in the list is, okay, one of the element is the list is greater than the middleman. Okay, in such a way, if you have to, in such a way, if you have to if you have to divide the list means you should not get the conclusions. Okay, this is the very important one. Here, binary search means the finding the middleman to ordered list. If anybody can ask, suppose what is the reason you can find out the list should be in ordered means. Okay, these are the conclusions. If the element is the middleman is once find out the middleman, the left list having the either less than greater than of the middlemen or right list having the either less than or greater than of the right list means, okay, you will get some conclusions if you have the order list. If the list is not order list, okay, finding the middleman means I think no use of finding the middleman. That is the reason. Okay, for everybody says that is a middleman. What is a middleman? Finding the middleman, the list has divided into two parts. Some of the people they don't know the element should be in ascending order only. No need of ascending order. Ordered list, either ascending order or descending order. Either ascending order or descending order. Suppose what is the reason the list should be ordered? Finding the middleman means, okay, we'll get the conclusions. Once you can find out the middleman, the left list elements are less than the middleman. Suppose the list is in ascending order, the right list elements are greater than the middleman. Okay, you will get these conclusions. Okay, then the list has divided into two sublists. The two sublists means the mid is divided the list into two sublists means the left sublist, all the elements of the left list should be less than the middleman. All the elements at right sublist, okay, should be greater than the middleman. If and only if the list should be in ascending order. Descending order reverse. Okay, descending order reverse means the left list elements are greater than the middleman. The right list elements are less than the middleman. Okay, these are the conclusions for descending order. Okay, in the previous what I said, those are the conclusions for ascending order. Okay, fine. Suppose here if I have to find out, okay, 40, this is the 40, okay, this is the 50. Now, if you want to search the 50, directly you can calculate the mid value. How can you calculate the mid value? It's very simple. How can you calculate the mid value? Low plus high by 2 is equal to mid. Once you find out the low plus high by 2 mid, okay, come to here. Here low is equal to, here low is equal to 0. Low is equal to 0. High is equal to 9. Okay, 0 plus 9 by 2 means what is the mid value? Mid is equal to 4. Okay, that is 4.5, but the mid, no 4.5 position. Okay, we'll take it as an integer, that the value is 4. Okay, now which is the fourth element? 0th element, first element, second element, third element, and fourth element. If my searching element is 50, how many comparisons are required here? With a single comparison, you will get the element. Suppose in linear search, how many number of comparisons are required? Suppose we will start from starting. Okay, 1, 2, 3, 4, 5 comparisons are required. Okay, finding the middleman. At starting, you can find out the mid element. If the mid element is a searching element with a single comparison, suppose here 10 elements, suppose the 1 lakh elements, 58,000 element is a searching element, means with a single comparison, okay, we found the element. With less number of space means you cannot identify here. Suppose the more number of elements in the list means, suppose the 50th element is a searching element, then you can say with the single, only with a single comparison, okay, you will find the element. Okay, this is a very important point here. Okay, once if the searching element is not a mid element, okay, if the searching element is not a mid element, then okay, what is the conclusion here? What is the searching element? What is the relationship between the mid element and searching element? Okay, what is the relationship between the searching element? Already we have the two conclusions. If it is ascending order, left list elements are less than mid element, right list elements are greater than mid element. Okay, then here you can say if the searching element is less than mid element means, okay, that element may be, okay, maybe it is presented at left list only, but not right list. Suppose if I want to search the 30, okay, if I want to search the 30, what is the mid value here? Mid is equal to 50. The mid element is greater than searching element. What is the mid element here? What is the searching element? 30. Okay, 50 is greater than 30 means then you have to choose the left list. Whether it is present or not, that is secondary. You have to choose the left list. Once you can choose the left list means off of the right list will be, no need to search in the right list. That means in every iteration, half of the list you have to eliminate from the search. That is called as binary. Binary means two. The list has divided into, in every iteration, the list has divided into two parts. Okay, with the reference of mid value. Okay, with the reference of mid value. Okay, fine. Next one. Okay, suppose what is the algorithm? Okay, like this you have to find out from beginning to what is the first mid value. Suppose once you have to move from either left or right. Next, once again you have to find out what is the sublist, what is the low value, what is the high value, and once again you have to find out the mid value. Okay, for that, okay, here I have to write it, what is the algorithm. Here algorithm. Okay, what is the algorithm? Bubble sort. What is the input space here? In the last class, I explained what is the input space. Here, array and data or key, which is the key. Okay, key, and also what is the size of the array. Okay, now we can start to write the algorithm. Okay, here, when you have to stop, that means while low value is exceeding the high value, then you can stop the search. Low value is exceeding the value. Exceeding the high value means simply you can stop it. That means you have to write it. What is the reason? I will explain. Low is less than or equal to high. If low is less than or equal to high. Okay, here you have to find out while low is less than or equal to high, then okay, you have to find out the mid value. Mid is equal to low plus high by 2. Low plus high by 2. Next. Okay, if you have to, suppose before going to here, suppose two elements are compared, means you will get the three kinds of possibilities. Two numbers are equal, or one first number is greater than second number, otherwise second number is greater than third number. Three conclusions. Wherever in the nature, wherever two numbers, if you two objects, if you want to compare, you will get it three possibilities. Okay, you will get the three possibilities. The first possibility may be two elements are equal. Otherwise, the first element is greater than second element. Otherwise, the second element is greater than first element. Okay, one of the choice should be satisfied. One of the choice should be satisfied. Here, I have to write it. The first one. Okay, what's the first condition? If array of I is equal to key, then key. Next, okay, if array of I is equality key, then means this is the equality condition. Equality condition means printf element form. Element form are written. Once element form, okay, no need to check the remaining. Next, LCF. What is the another one? Array of I is greater than key. Then look here. Suppose the elements are in sorted order. That is ascending order. One kind of action you have to take. If it is the descending order, another kind of action you have to take. This is the very important point in the linear search. What is the order of the list? Suppose here in our example, the elements are in sorted order. Which order? Ascending order. Ascending order means, look here, if array of I is greater than key, not I here, sorry, it's the mid. Array of mid. Array of mid is greater than key means, array of mid, suppose if I want array of mid, look here, what is the array of mid? Suppose I have the elements here. Okay, take this example. 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100. Okay, here what is the mid value? Mid is equal to 50. Okay, mid is equal to 50. Okay, look here, if I want to search the 30, suppose I want to search 50. Okay, then what is the low value? Initially, low is equal to 0. Initially, low is equal to 0, high is equal to 9 as per above input. Okay, low is equal to. Now, while low is 0 is less than or equal to high. Okay, condition is 2. Mid is equal to 0 plus 9 by 2. That's the 4. Next, if array of I, array of mid, not I here, this is the mid, sorry. Okay, if array of mid is 50, your key is also 50, then element form return. How many comparisons are required here? With a single comparison, found the mid element. Suppose my searching element is 30. Okay, my searching element is 30. Okay, now array of mid is greater than key. What is the array of mid here? Array of mid is 50. 50 is greater than 30. Okay, 50 is greater than, this is the searching element. Okay, for this I have given a red mark. Is right here. This is the red. Okay, in this input space, I want to search 30. Mid value is 50. Okay, mid value is greater than the searching element. That's the key. Okay, then you have to choose the sublist. Okay, you have to choose the left sublist. Okay, here, what is the left here? Look here. Okay, this is the low, 0. Okay, where is the, this is low is equal to 0. Low is equal to 0. Okay, then, okay, suppose you have to choose, this is the list means, where is the actual high here? This is the high. This is the high. High is equal to 9. Now, which is the sublist? Okay, 10 to 40. This is the sublist. That means no change of low. You can choose the left list means no change of low, but the high is equal to mid minus 1. High is equal to mid minus 1. Mid minus 1 means, okay, just you have to write it. High is equal, choose the left list means change the high value, choose the right list means change the low value. High is equal to mid minus 1. High is equal to mid minus 1. Okay, then suppose if you want to search, suppose else, no need to write else, simply will go with else. Okay, then that's not equal, that is not greater than, suppose if I want to choose the 80, this is the searching element. Okay, 8 is the searching element, then mid element is not, A of mid is 50 is equal to 80, no, 50 is greater than 80, no, then you will go to else. Okay, here you have to write it. Okay, but now we can choose the right list. If you can choose the right list means, okay, just now I said that if you can choose the right left list means, suppose this is the left list, sorry, this is the right list. High is, we have to, no need to change the high value. Choose the right list means no need to change the right value, because of this is the sublist means what is the position of, what is the starting position of the right sublist here? That is the 5. Actually, what's the mid value? Mid is equal to 4. Now, okay, in this condition, okay, we have to change the low. Low is equal to mid plus 1. low is equal to mid plus 1. This is the algorithm. Suppose if all the iteration, if the condition low is less than or equal to high is failure, then you can say print, okay, element not found. Element not found. This is the not bubble. Sorry, this is the binary search. Okay, this is the algorithm of the binary search. Okay, now you can start to find out. Okay, 30. Okay, I want to search the 30. Okay, what is the reason here low is less than or equal to high means? Okay, sometimes low and high are reaching the same position. Whenever the low value is reached to high value means the list size is only one element in the list. That is, list size is one element. Maybe that element is also searching element. Suppose you can write here while low is less than high, if the list size becomes 1, if it is a searching element, you can lose to find that element. This is a very important point. What is the reason while low is less than or equal to high? Instead of while low is less than high, what is the reason low is less than or equal to high? Here we are writing the condition means low is reaching the high value. Suppose low is equal to 2, high is equal to 2 means the list having the single element. Once the list having the single element, that means what is the condition while low is less than or equal to? You have to search the elements, okay, up to the list having the single element. That is the meaning of the low is less than or equal to high. At that time, suppose if the element is not found, low is greater than, low is reaching the greater than high value, simply you can stop. Okay, look here, I have to search 30. Okay, then a of low is less than or equal to mid is equal to 4, a of 4 is equal to key false, a of k for 50, a of 4 is 50 is equal to 30 false. Okay, then you will come to 50 is greater than key. 50 is greater than key means now what is the high value? High is equal to 4, mid minus 1. Okay, this is the 4. Okay, half of the list has eliminated from the sort search. This list no need to search. Okay, in this list half of the list has eliminated. Then okay, what's the low value? Low is equal to 0, high is equal to 4. Then once again, while low is less, 0 is less than or equal to 4. Next 0 plus 4. 0 plus 4 means 4. 4 by 2 means mid is equal to 2. A of 2. What is A of 2? This is the 2. This is the 0, this is the 1, this is the 2. A of 2. A of 2 is equal to, what's the searching element here? Key element 30. 30 is equal to 30, element found. How many comparisons are required? Just 2 comparisons are required. Okay, suppose I want to search 31. Okay, I want to search 31. Here also, A of next 30, 31. Okay, 31 is equal to 30 is false. Okay, then you will go to 31 is greater than key. Okay, A of mid. 30, the A of mid is 30. Okay, key is 31. 30 is greater than 31. 30 is greater than 31 is false. Now you have to change the low is equal to mid plus 1. Okay, what's the mid value? Mid is equal to 2. Low is equal to mid plus 1 means, okay, low is equal to, what's the low? Low is equal to mid plus 1. Actually, which is the mid here? Mid is equal to 2. Okay, low is equal to mid plus 1. Low is 2 plus 1 means 3. Okay, 2 plus 1 is equal to 3. Sorry, this is the, actually in the previous, this is 3. Okay, now low is also 3. Low is equal to 3, high is equal to 3 means, okay, what's the meaning of low is equal to the list having the single element. Now this is the 40. Okay, then you will come to mid is equal to 3 plus 3 by means, that is a 6, array of mid. Array of mid means that is, okay, 40. 40 is equal to 31, no. 40 is greater than key, 40 is greater than 31. High is equal to mid minus 1. High is equal to mid minus 1 means 3 minus 1 is equal to 2. Now what is the high value? High is equal to 2. Okay, then low is less than or equal to high. Low is less than or equal to high here? No. 3 is less than or equal to 2. Condition failure. Condition failure means 31 is not in the list. Very simple. 31 is not in the list. Okay, this is the concept of the binary search. Okay, this is the concept of the binary search. You have to test this one. Next one, what is the next one? Okay, here input space is, I think for in the last class I said that what is the input space? This is the input space. What are the processing variables here? Low, high, and mid are the processing variables. Key is the input space. Next, how can you write the program? Okay, for that you can write the program. How can you write the program here? First of all, what is the linear search program? Up to reading the array. Up to reading the array and also finding what is the key value. Read the key value. After that, okay, this is also for binary search program also same, but with small modifications. Just you have to declare the what are the inputs. What are the inputs means here mid input variables are sorry processing variables are low, high, and mid are you have to declare. Just you have to save as the program and modify the program. Okay, then how can I write the program here? Okay, suppose void main. Okay, just I have to write it. This is actually this algorithm is looks like a C algorithm. Okay, looks like in same format. Okay, here this is the while low is less than or equal to high. This is the function. Just you have to call the function. Here I am writing the binary search function only. Void binary search. Okay, void binary search. What are the inputs here? Int array. Next one, int key, comma, int size. Three requirements here. Then you have to start it by research. Okay, what are the variables are required here? Int mid, comma, low, comma, high. Int low, comma, mid, comma, low, comma, mid, comma, high. Okay, then here, okay, you have to find out what is the low value. Low is equal to 0. For any list, low is equal to 0, high is equal to size minus 1. High is equal to size minus 1. Okay, then you have to start the algorithm program. Okay, while low is less than or equal to high. Low is less than or equal to high. Then, okay, you can write it. What is the next step in the algorithm? Mid is equal to finding the mid value. Low plus high by 2. Okay, low plus high by 2. Next, okay, we will start the decision making. If a array of mid, if array of mid is equality key, if array of mid is equality key, okay, no need of then all these things. That's not a syntax of the C program. Okay, then printf element found. Printf element found. Once element found, no need to check the remaining. Simply you can return from the function, binary search function. Okay, next one, else if array of mid is greater than key, suppose the order is ascending order, change the high value, high is equal to mid minus 1. Okay, else means greater than, simply will write it low is equal to high plus 1. Low is equal to mid plus 1. Okay, then printf element not found. This is the binary search function. Okay, just cut this and show in single page. This is the binary search program. Very simple. Okay, this is the binary search function. Okay, for this the binary search function for integer array. Correct? Okay, here simply you have to find out the mid value. Regarding that mid, suppose if it is the elements are in this descending order, okay, simply you have to access these two statements. If the elements are in descending order, simply you have to access these two statements. That's enough. Okay, here my question: which one is the good algorithm here? As per searching technique, binary search is the best than linear search when if the input space is more. Input space is more if the searching element is suppose if the searching element is starting position and ending position, linear search is good. Otherwise, binary search is best case. Okay, here the time complexity for binary search is here. That is log n base 2. Okay, log n base 2. Okay, what is the time complexities in the coming classes? I will tell you what is the time complexity. Time complexities here. Okay, first of all, suppose what is the basic criteria for binary search? You have to the input space should be sorted order. Okay, for suppose if my input is in sorted order, your program okay will be sort your inputs into any one of the sorted order, then you have to search the binary search. Then you have to follow the binary search. Okay, here, how can you say the binary search is here efficient than linear search? In linear search, no need of sorting. Suppose the sorting is also applied in your program, you have to write the code for binary sorting, and then once again you have to write it binary search means what is the time complexity for sorting? Big O of n square. What is the time complexity for search? That is suppose n by 10 by 2 n log n base 2 for binary search. Okay, that is n square plus n log n base 2 is the actually the time complexity for binary search. How can you say binary search is the best good for means? Okay, before that you have to sort the elements. Otherwise, you have to give the sorted list as an input. If your input is not in sorted order, then you have to convert your list into sorted order. It takes the time. For sorting algorithm, you have to apply any one of the sorting algorithm. That means whatever the sorting algorithms, most of the sorting algorithms, time complexity is big O of n square. Okay, big O of n square after sorting. Okay, most of them in interviews, okay, they are asking what is the reason. Okay, what is the reason? Okay, suppose why you can say why you can say binary search is the best. Binary search is the best technique means okay, we don't have the answer because of the time complexity for binary search is log n base 2. But as per the input, okay, the elements not in the sorted order, you have to sort once again. You have to sort once again means you have to use any kind of in such a way you have to give the answers. Okay, in this reason, the binary search is not good. Suppose the elements no need of sorted list for sorted list, no need of sorted list for linear search, but in the binary search, you need the sorted list. For if your elements are not in sorted list, before going to search, you have to sort your list. Okay, in such a way, you have to answer the interview. Most of the interviews they can ask the question, what is the reason the binary search input, the input space should be in the order? How can you say it is the best technique? Okay, as per every algorithm having its pros and cons. Okay, at the same time, binary search also having its own pros and cons. Okay, I think this is the algorithm binary search. This is the program for binary search. Okay, here you have to run the program in any tool. Okay, in any turbo compiler or code blocks or whatever the software you have to use for to run. Don't test the input with a single kind of input, single search. That means I have to give the 10, 20, 30, 40, 50. Okay, then I can find out the mid element. Okay, my work is over means it's not correct. You have to run the program. What is the input space? Search each and every element. Okay, each and every element. Take the input space is very less, 5 or 10. Take the 5 minimum, maximum is 5. 5 is enough. You can run with 10, 20, 30, 40, 50. In the first run, search the 10. In the second run, search the 20. In third run, search the mid element. In the fourth run, check the elements in the right list. Each and every element in the right list, each and every element in the left list, and also find the search the mid element. Finally, if the element is not in the list, you have to check that one also. That means 5 elements in the list means how many number of times you can run the program? 6 number of times you can run the program with all the inputs. Every run, okay, with every run you can give the one position element. Okay, suppose first you can give the mid element. Okay, then search it. If element fall, suppose, then you can take the input from the left list. You can take the input from the another element in the left list. How many number of elements in the left list? You have to search each and every element. Okay, this is the good practice. Because of why I am saying here means most of the students nowadays, once they will get the answer means they feel very happy. They feel very happy, but it's not good. Sometimes you have to test your program, okay, until you can get the bug. Until you can get the bug in such a manner, you can test your program. You will become a very good tester. You will become a very good tester. The developer having the 2 eyes means the tester having the 1,000 eyes, because of the tester duty is finding the bugs in the program. Finding the bugs in the program. Okay, for that, okay, always he is watching, finding to what are the bugs, not errors. Errors are different. Bugs. Okay, what are the bugs? Suppose your program input is integer. Suppose I have to give the another kind of input. The program will not be satisfied. Like that. Okay, that means like that you can think as a not a developer. You can think as a user. You can think as a user the how many types of users you can keep you have to keep all the users. What are the different types of users? What are their thoughts? All you have to keep in your mind before writing the program. Once in such a manner you can try to write the program, you will become a very good programmer, very good developer, because of no need of testing also, testing department also. But a developer never seen, okay, what is the sometimes, okay, the developer can miss the some of the bugs in the next version they can solve. Even sometimes the tester cannot identify the bugs. Okay, even the tester cannot identify the bugs. Okay, in such a manner, okay, you have to learn the subject. Okay, binary search means simply this is the technique means, okay, you have to